As a group, we decided on some set requirements that each of our designs must fall into. All instruments are required to play at least one of the given songs. Each team member will create one instrument. Within these instruments, they must have at least one wind, one percussion, and one string. Seeing as though we have 4 group members, one of these will be made twice. All of the instruments must fall within a $15 budget. With all of the instruments, they must be able to fit into a 2-foot by 2-foot by 2-foot box. And these designs must be creative and aesthetically pleasing.
This is our group's decision matrix. Each person on our team suggested a design solution consisting of 4 of our different instrument concepts. These were then evaluated and graded based on how well they fulfilled our requirements. As you can see, design 3 proved to be the most effective design submitted. Each team member then chose an instrument to present on. Mine is the Salterio box. As a team, we decided my instrument would play low-range frequencies. My simple design will help new players effectively learn how to use the instrument. Using chipboard helped me keep the cost to create this instrument under $15, and the different string lengths will play several low-range frequencies. The instrument is small at 12 by 8 by 4 inches and will fit comfortably in a 2 by 2 foot box along with the other instruments in our design solution. In order to determine the ideal string lengths to generate the frequencies I needed, I referred to the graph I created for our modeling acoustics assignment. Using the graph, I chose several string lengths that might generate low-range frequencies under 250 Hertz. To test if these string lengths would perform as needed, I calculated the fundamental frequency for each string length on my instrument. My calculations prove that the string lengths I chose are viable solutions. Finally, I compiled a list of materials I would need to create my instrument. I found that guitar bridge pins would serve as great pegs for my instrument. Similarly, other guitar elements will be used in its construction, such as guitar bones and strings. Luckily, all of these supplies bring me just under our $15 budget.
For myself, I will be building the xylophone with 5 keys. As it does have 5 keys, it will be able to play medium frequencies varying from the low end more towards the high end. This design stays within our $15 budget, and with a profile of roughly 10 inches by 10 inches by 5 inches, it's able to fit into the 2 foot by 2 foot by 2 foot crate perfectly, leaving plenty of space for the other instruments. In my opinion, the design will be aesthetically pleasing once it is complete. And as you will see later on, the mathematical equations for this prove that the instrument will have frequencies within that medium range. As this design does not use any of our limited materials, we don't have to take that into consideration at all. This instrument will also not be built using a kit, and it will not be bought. As you can see on this slide, the materials used are as follows: wooden planks for the casing, and then wooden planks for each of the keys, and then brass pegs holding down the keys, and a wooden dowel plus a part of that wooden plank will be the mallet to strike the keys. All in all, the design will be roughly $14, which is underneath our $15 budget. As you can see here, the mathematical equations prove that with each length of the keys, different frequencies will be played, but all of those fall within the medium frequency range.
For our proposed design number 3, we have the kalimba. The kalimba is a percussion instrument designed to play mid to high frequency tones. It's a hollow wooden box measuring 8 inches length, 6 inches wide, and 2 inches high. The box contains a sound hole in the center, which enhances the pitch. It has 13 metal bars with different lengths that are plugged with the fingers to create different tones. The bars are cantilevered with a hollow brass or aluminum 5-inch tube. The equipment can be easily tuned by adjusting the length of the bars themselves. Bars of different thickness can also be added to create lower frequencies as desired. It has a very economical design, small footprint, and is very easy to use and is very portable. Mathematical calculations have been created of the second harmonic to generate the higher frequencies. that we're searching for in the specific project. With the use of MATLAB, we utilize the equation of model frequencies for cantilever bars, and we enter the values that you see there in the middle. This resulted in a graph on the left, indicating that the frequency proportionally goes up as the length of the bar decreases. Lastly, for the material, we're proposing to use 2 wooden boards measuring 8 inches by 6 inches, 4 wooden sideboards, 1 brass tube, 13 rectangular metal bars, 2 round metal bars, and this brings our total estimated cost to $13.50. Thank you.
Hi, my name is Nathan Barrett, and this is the Native American style flute. This flute is designed to be constructed out of 9 inches of 1-inch diameter PVC tubing, 1 inch of recycled thermoplastic used for the mouthpiece, and a 1 1/4-inch piece of PVC tubing designed to slide over the main flute body, allowing the user to control for tonality and pitch over a hole in the main flute. This sliding mechanism is the main reason why this flute is Native American inspired. My instrument is going to provide the high frequency range for my team's band in a box. Because of this, I had to choose 4 high frequencies to create for the flute openings. Each opening, when uncovered, produces a particular frequency, allowing the users to combine these frequencies to create notes. Each of these locations of the holes were created using MATLAB to provide for a calculated and easily predictable experience. This instrument was created using economical materials and will be very easy to create. One design benefit includes countersunk holes, allowing for the user to create a vacuum and produce the intended note more easier. The entire Band in a Box team was committed to providing an economical solution to the band, as well as providing creative and well-polished instruments.